Good day everyone! Welcome to video presentation of Group 3. For today's video, we will tackle about concentric circle of nature. But before we start to our discussion, let us introduce first my team member.
My name is Genevieve Precioso from Foxtrot. I am Jerlison Perez from Foxtrot.
My name is Lijan Morundos from Foxtrot.
My name is Sam Tagulay from Foxtrot.
My name is Jose Melchor Sumalpao from Foxtrot.
My name is Silbertin Buscado from Foxtrot.
My name is Kenneth Daryl Mahinay from Foxtrot. My name is Clifford Ibusico from Foxtrot.
My name is Claudio Villadra from Foxtrot.
My name is Ryan Remedios from Foxtrot.
Gonros Del Molig from Foxtrot.
So they are the team member of Group 3, and also, by the way, I'm Kenchan Purpose, the leader of Group 3. So let's start our discussion about concentric circle and nature by questioning what is concentric circle and nature. Concentric circle are circle with the same or common center. In other words, if two or more center point be termed as concentric circle. So let's watch this video presentation and ask to have a deeper understanding about concentric circle.
Concentric circles. Draw a circle C1 with center O and radius equal to 2 centimeters. With the same center O and radius is equal to 3 centimeters, draw another circle C2. With the same center O and radius equal 5 centimeters, draw a third circle C3. We say that these circles C1, C2, C3 are said to be concentric. Concentric circles are circles having the same center but different radii. Here, in the given figure, we observe that the three circles C1, C2, and C3 have the same center O.
So we are done defining what is concentric circle of nature. So now let us proceed to the geometric properties of concentric circle. So the geometric properties of concentric circle called annulus. Annulus is the region between two concentric circles. So let's watch this video presentation and ask to have a deeper understanding about the annulus.
In two-dimensional geometry, consider two circles with the same center. Then the region formed in between the circles is called the annular region. Simply speaking, annulus is a plane circular ring shape formed when two concentric circles are drawn in a plane.
There are three concentric circles are known as inner circle, outer circle, and expanding circle. So this is the picture of three concentric circles. In the inner part is the inner circle, and the second part is the outer circle, and the last is expanding circle. So let us proceed to the equation of an annulus. So area of an annulus equals to pi multiplied by inner circle squared subtract by outer circle squared. Close and open parenthesis. So this is the equation of an annulus. For us to solve this problem solving, the first thing we will to do is to write the formula. So area of an annulus equals pi multiplied by inner circle squared minus outer circle squared. Close and open parenthesis. Copy the area of an annulus equals pi multiplied by 5 squared minus 2 squared. Close and open parenthesis. Third is multiply the inner radius and the outer radius. Fourth is subtract the inner radius and outer radius. Fifth is the total of inner radius and outer radius is multiplied by 3.141 for pi, and the final answer is 65.95 or 66. So this is all the coverage on concentric circle and nature. Any question or clarification? So let's watch this video presentation to answer this following question. So this is the question number 1. What math concept is fully discussed in your video assignment? This is the answer of my team member.
There are many real-life applications for tessellations. Hobbies, art, architecture, and carpets are only a few of the places that tessellation can be found in our world. And one of these is the street pavements. One of the relative few applications tessellation has it is use of actual street pavings. Pavings as such as a long history seen worldwide.
Constellation is a special type of violin or using shape or surface are no gap or overlaps. I think the example of in real life are the file floor, chessboard, break fall, and display fall are using of franchise hub.
The math concept that is fully discussed in my assigned video is the tessellation. It is a pattern made of one or more shapes, whereas the shape must fit together without any gaps. The shape should not overlap, and tessellation also called as appealing, where all the covers of a pattern meet at a point called vertex. It has 3 basic shapes in tessellation: triangle, hexagon, and squares. Tessellation can be regular, semi-regular, or irregular, where it is very useful to create a pattern that can use in design and abstract.
The math concept is fully discussed in a assigned video is all about tessellation that repeats to make a pattern, and there are 3 basic shapes of tessellation. Number 1, triangles. Number 2, hexagons. And the last is squares. A pattern of shapes that fit perfectly together. A pattern of tessellation is when we cover a surface with a pattern of flat shapes so that there are no overlaps or gaps.
So this is all coverage of concentric circle in nature. Any question or clarification? So let's watch this video presentation to answer this following question. So this is the question number 2. What is about this concept? Cite few more word cases or example that would show the concept. And this is the answer of my team member.
Tessellation or tilling is a covering of a surface, often a plane using one or more geometric shape called tiles, with no overlaps or no gaps. In mathematics, tessellation can be generalized to higher dimension and a variety of geometrized periodic tilling has a repeating pattern.
Tessellation is created in a shape, is repeated over and over again, covering any gaps and overlaps. The example of tessellation is can found in many areas of life, art, architecture, and tile floor.
This is the question number 3. What is your insight about mathematical truth and certainties? And this is the answer of my team member.
In summary, concentric circles are mathematical truth that can be observed in various natural phenomena, and their properties and symmetrical nature make them a fascinating subject in both mathematical and the natural world.
Concentric circles display a high degree of symmetry, which is a circle with having the same center point. This symmetry is fundamental aspect of their mathematical nature and is often found in natural structures.
Mathematical truths are fundamental principles in mathematics that are proven through rigorous logical reasoning. They form the foundation of mathematical knowledge and provide a solid basis for problem solving, objectivity, and universal, transcending cultural boundaries. They are mathematical proof which starts with axioms and applies logical reasoning to deduce the truth of a statement, ensuring they are valid and considered true of all time.
This is an example. Growth patterns. Many natural phenomena such as tree rings ripples in water and the layers of an onion exhibit concentric circle as they grow or expand. These geometric patterns arise due to the way these objects develop over time.